syllabus index book series, as well as it is say submitted to Thomson Reuters for indexing. Secondly, in 2016, probably it is a subject started during 90s. However, it was say entered into the syllabus of MTech and PhD syllabus during 2014-15 in our university. So when it was allotted to me, so I'm sharing my personal experience, don't get bored. So why I'm telling, it has a purpose. So for the first time, it was allotted to me in 2015, and the first batch of student PhD enrollment was there. So nature-inspired computing was a new topic, and of course, it is the other name of meta-heuristic. And each chapter, it was a new technique, say particle swarm optimization, fish school, say simulated annealing, all those things. So what I did, I assigned one area to one PhD student. So I told them, you go through, collect the material, prepare the slide, and you present, then I'll listen. So there are four parts, and the fourth part was the nature-inspired computing in computational intelligence. So they had prepared everything, and thanks to those students, probably some of them might be attending the class here, attending the session today, and they have presented very nicely. And out of that, I was motivated, and I prepared book proposal for Springer. The name was Nature-Inspired Computing and Optimization. So name was NICO, N-I-C-O. And my scholar, one of my scholar who was continuing PhD during that time, he helped me, and we got around more than 25 chapters from different part of the globe, and it was a very good outcome we presented in 2017. And along with me, Jinsi Yang, who is a pioneer in meta-heuristic in Middlesex University, UK, he is a co-editor of this book. So this is the journey, and this is my personal, study or personal association with meta-heuristic. But frankly speaking, I have very little work in say software engineering, so I cannot say what is the application of meta-heuristic in software engineering. So I welcome you all to all the participants that you please refer to the book series Modeling and Optimization in Science and Technology. Whenever you are getting any opportunity to contribute a chapter or a book proposal, you are most welcome. And I'll process it through Springer. And I congratulate the organizer for organizing this conference in a very, say, advanced area, and that too software engineering application. So I congratulate all the organizers. Thanks to all the participants who are attending virtually as well as from the university premises. With this, I remain. Thank you all.
Thank you, sir. Now I request our General Chair, Professor Mihir Narayan Mahanti, to say a few words about this conference. Now I request Professor Mihir Narayan Mahanti, sir.
Yes.
Sir, are you hearing me?
Good afternoon, sir, our colleagues and our participants. I welcome everyone here. Srikant sir has already told the details about the conference, and it is only the inspiration of our chairman and our HOD, Dr. Devaki Mishra. Just it is conducted. Actually, the same concept I have learned from Srikant sir, Dr. Srikant Patnaik. He has ensured as well as inspired to continue all sort of things regarding the innovative things. So I hope the innovation based the chapters can be included in Springer, and this is also the new series started of Springer, and you can enjoy these days by exchanging the research idea, and we can work over it in future years. So thank you so much. Enjoy this conference day. Thank you very much.
Thank you, sir, for your nice talk. Now, I welcome you again. I welcome you all to this conference, Meta-heuristic in Software Engineering and its Application. On behalf of this organizing team, I would like to thank our organizing chair, Professor Debhuti Mishra, Madam, for her nice talk. She has made an excellent presentation and making this conference more interesting. I would like to express our deep gratitude to the Director, International Relations and Publication, Professor Shrikant sir, for his talk. Now I would like to express my gratitude to Professor Bhavani Prasad Sinha sir, to our General Chair Mihir sir, to all the organizing team members present here, and all the participants. Again, I would like to thank all those who have taken their time, giving their time for this conference, all the lab staffs, those who are present, those who have also taken their time for this conference. They have made a lot of effort to prepare the website and other things are there. Now, I would like to express our gratitude to other members of other HODs of CSC IT and computer application. Thank you all. Now our next keynote session will start. Keynote session will start at 2:30. Anyone wants to say anything regarding this conference? They are most welcome within this time. Our next keynote session will start at 2:30. Regarding this conference, if you can say, it basically consists of 3 tracks. First track is meta-heuristic algorithms. Second track, the optimization algorithms in software engineering, application of meta-heuristic in software engineering. Third one is machine learning and its application. So it's basically a broad area, not only though it is meta-heuristic in software engineering and its application in various areas. So it deals with a lot of things, and we have collected a lot of paper from various reputed organizations inside India and also outside India. And thank you to all the members present here. Thank you to our convener, another convener, Dr. Vichitananda Patra, for giving a lot of time for this. Without his effort, it's very difficult to make it successful. We have collected a lot of paper. Now we have 2 days paper presentation, 11th and 12th. In that, we are going to present 52 papers. 52 papers that will be in 2 tracks, the 3 tracks that will parallelly, it will continue. So thank you all. Our next session will start at 2:30, the keynotes.
Just he will join. He will join. Professor Sarma will join.
Okay, sir. Regarding our keynote speaker, Dr. Kumar Sarma, let's introduce him. He is the professor, Department of Electronics and Communication Engineering, Guwahati University, Guwahati. He will be here and he will give his nice presentation on radio location and cognitive techniques. So we'll wait for him.
Hello, Professor Sarma. I am Srikant Patnaik speaking. How are you? Just a minute, I have some problem. Yeah, now it is audible. I think your microphone is off. Your microphone is off.
Yes.
Yes, sir. Yes, sir. Sir,
Yeah.
yes, talking to you, and it's nice to talk to you. It felt so nice to see you directly. I had been to your premises in 2019 for
Correct.
one some PhD some Bhaiga.
Yeah.
I that time just the schedule was so tight, so I thought to go and say you hi, but I failed to do that. Sorry for that.
No
Next time I
issue.
go there, I shall personally go and meet you and talk with you. It's so
Sure,
nice
sure.
to see you.
After
directly.
maybe 10 years after we are meeting.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Great,
So
great, sir. Great.
during that time, you are just doing PhD.
Yes, sir. Yes, sir. Yes, yes, sir.
How is your wife? How is your
Yes.
madam?
Yes, 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 yes.
Yeah.
Great.
Okay, okay. So your wife is where working?
Yes, my wife is not working.
Not working.
She is at home.
Okay.
Since home is also a very complex workplace. So,
Yeah.
so yes, she deals with all that home,
Correct.
home, and for
Correct.
that reason our life moves well.
Yeah. So welcome to this gathering.
Thank you.
I hope to meet you again frequently.
Yes.
Thank you.
Thank you. Thank you.
Mitra Binda Roy, you can start the proceeding.
Yes.
Mitra Binda, your microphone is off. Mitra Binda, your microphone is off.
Welcome, Dr. Kandarpa Sarma. Just 1 minute. Welcome, Dr. Kandarpa Sarma, to our conference. Let me give some introduction of Dr. Sarma. Dr. Kandarpa Sarma is currently Professor and Head, Department of Electronics and Communication Engineering, Guwahati University. He is specialized in mobile communication and subcomputing, machine learning, antenna design, and over 17 years of professional experience. He has taught all areas of UG and PG level electronics courses, including subcomputing, mobile communication, pattern recognition, digital signal and image processing. He obtained MTech in signal processing in 2005 and subsequently completed PhD in the area mobile communication, both from IIT Guwahati, Assam. He has authored 7 books, several book chapters, several peer-reviewed research papers in international conference proceedings and journals. His area of interest are subcomputing and its application, knowledge-aided system design, mobile communication, antenna design, speech processing, document image analysis, and signal processing application in energy physics, neurocomputing, and computational models for social science applications. He is a senior member of IEEE, fellow IETE, member of International Neural Network Society, life member ISTE, and life member CSI. He serves as an editor-in-chief of International Journal of Intelligent System Design and Computing, guest editor of several international journals, reviewer of over 30 international journals, and his topic is radio location and cognitive techniques. Now I request Dr. Sarma to start his talk. Dr. Sarma, kindly you start your talk. Sir, your mic is off.
Yes. Just thank you for your nice words. I will start my presentation now. I am sharing the slides. Good afternoon to you all. My presentation is titled Radio Location Cognitive Techniques. This is my plan of presentation. Significance of radio location, cognitive radio, radio location with cognitive radio. So I have just mentioned here three broad topics, but I will try to cover all these things in some detail. Whenever you find that there is a doubt, you can please raise questions. I shall be pleased to reply all your queries. Now, these topics have become very relevant because our day-to-day lives have become very much dependent on the wireless techniques, wireless methods, wireless systems. Now, why we need the radio location? We need the techniques of radio location because with the help of the radio frequencies, we can determine the location of the users and vehicles, especially. Now, radio location is significant for several reasons. One is to provide location-based services. Then one to have a eye on the vehicular movement. Then further focus on the wireless network resource management. And then lately, radio location has become very significant for fighting crimes. Now, why radio location is so much significant for vehicular traffic? This is because of the fact that nowadays, due to the roads becoming better, surface communication becoming better, we find that the speed of the vehicles are rising. So when the speed of the vehicles are rising, traffic becomes smooth. The navigation part too is also a very significant factor. It turns out to be a very critical factor in many situations. If we do not have a proper know-how regarding the traffic problem, our journeys become very difficult. We face lot of traffic jam. And further, if there is a crash somewhere, or if there is a crisis somewhere, we need specific location details where we can provide support. So in these situations, radio location plays a very significant part. Now, this is a situation quite common. We come across vehicular networks. Now, in the vehicular networks, we see that there are roadside base stations. There will be wireless communication devices in the vehicles. Now between the nodes that are nearby the roadside base stations, there are that these are near the roadside, and the nodes that there are in the vehicles, there will be a constant communication. So for this constant communication, we find that there is a huge resource of finding location of not only the vehicles, users, the nodes, but using the same detail to determine or to generate situational details, sense the situation, find out the surrounding situation. Now, since we are dependent on the wireless medium, we are dependent on the radio frequency. Therefore, the radio frequency systems come and play a very big role. But lately, for the sensing part to work in a reliable manner or in a much robust manner, cognitive radio has come in a big way. We can define cognitive radio to be a software-defined or a software-driven radio that permits the user or the network to control key parameters of a radio communication system, namely the waveform, frequency or the carrier used by the network or the subscriber, protocol, and the network profile. So if we have a cognitive radio gives us better control on the process by providing us smart and autonomous control of the radio system, sensing the surrounding, processing that is goal driven, tracking variations in the signal and the channel, and negotiate waveforms with the nearby radio system. And in the radio system itself, on top of a generic hardware platform, there will be a operating system on top of which there will be several layers of software which permits a wide range of flexibility and control through which the system is capable of regulating waveform, frequency, protocol, and the network's behavior. Now there are some key features of the cognitive radio. One of them is it is an intelligent system that can make variations in the system configuration. It is an autonomous platform, can sense the surrounding radio frequency scenario, can work both as transmitter and receiver. It has goal-driven characteristics, continuously senses its system, the surrounding, working, protocol, waveforms, and so on and so forth, can negotiate waveforms and cancel out the interference. So that way, cognitive radio is a very reliable and robust system. Now, why we need radio sensing, and let us now try to find out the key methods of radio sensing or radio location. Now, there are three types of radio sensing capacity. First is called spectrum awareness or spectrum sensing. Next one is called position awareness or position sensing. The third one is network awareness or network sensing. Now, spectrum awareness we can call to be the lifeblood of all radio communication system. We in our labs have the spectrum analyzers through which we can find out which bands are blocked, which bands are free. We can also find out where there are noise variations, where there are noise mix signals, which are the corrupting source of data, which are the disruptions that the signals are facing. So it gives us a very clear view. Now, if we can have spectrum sensing, we can say that we have the know-how of a communication system which gives us the complete status of how we are using the spectrum. Spectrum sensing radios have the capacity to manage interference and thus transmit the location and the utilization of the spectrum from a command and control structure. So it gives a complete picture regarding the spectrum. Now, there comes why we see the necessity of spectrum awareness. This is because complex spectrum management or complex spectrum capture is a factor that is linked with the management and its optimal use. We can figure out a noisy part of the spectrum. We can also find out if there is network densification. We can also find out if there is a rise in the RF applications. Then we can use the spectrum sensing capacity to reduce network operating costs. So there are many reasons for why we need spectrum sensing capacity. Now let us find out the key spectrum sensing techniques, the spectrum awareness techniques. The first one is the spectrum sensing. Next, to maintain a database. Then there is a environmental parameter estimation, and the fourth one is a waveform parameter estimation. Now, say we go further to find out the specific spectrum awareness methods which are used in the cognitive radio node to generate different levels of sensing. From the spectrum utilization point of view, the greater shall be the depth of sensing. There at the CR node, the better the spectrum utilization becomes. So we can collect spectrum sensing details like spectrum occupancy, signal to noise ratio of the primary user signal channel towards the primary user, modulation, demodulation, and coding techniques used by the pilot users, pilot structure, data format, then in the pilot in the primary user transmit frame, and so on. Now there are two broad types of spectrum awareness techniques. One is blind and the second one is non-blind. Now in the blind technique, it does not require details regarding the parameters related to the primary system, while non-blind techniques require some specific details concerning the parameter of the primary system. So if we go for the blind techniques, there is no requirement of the primary system's parameters like signal and channel. There we find there are two broad methods. One is the spectrum sensing method, and the second one is called the environmental parameter estimation. Now in the first type, there is an energy detection based method, then a covariance based method, then there is a autocorrelation based detector, then a eigenvalue based detector, then a feature detector, and a few more recent techniques. And in the case of the environmental parameter estimation, we need to find out the characteristics of the channel, then DOA and sparsity. Order. And in the non-blind method, here we see that we need to have some significant know-how regarding the signal and the channel. It can be linked with the database. It can be linked with spectrum sensing method, some spectrum sensing method, and it is linked further to the waveform parameter estimation. Now this database maintains some say mathematical model, a pilot structure, waveform structure. It maintains the channel nature details. It maintains some trace of the path gain of the channel. So there are some details regarding the profile of the signal and the channel. But non-blind spectrum sensing techniques can be further subdivided to match filter based method, feature detection based method, beacon based sensing, and some more recent techniques. While there are a few non-blind waveform parameter estimation techniques that use cyclic frequency prefixes, then it will use details of the modulation and coding decoding, then channel and pilot and data supported techniques, and further a few are signal to noise ratio based methods that are dependent on pilot and data supported methods. So we have gone through these techniques, so let us skip that. And if we say combine all these techniques, spectrum sensing techniques, we find that there are four broad categories through which spectrum sensing can be done. These are related to the signal processing techniques, signal bandwidth techniques, then coordination between the secondary users, and number of radio frequency change. So if we go for the signal processing techniques, we find that there can be energy detectors, we can find there can be match filter detection, we can find there are feature waveform based detection, we can also find that there are autocorrelation based sensing, covariance based sensing, eigenvalue based sensing, and a few more recent techniques. And with respect to the signal bandwidth, we find that there can be narrowband sensing, wideband sensing. So in the case of the wideband sensing, there can be Nyquist wideband sensing, sub-Nyquist wideband sensing, and in the Nyquist wideband sensing, we find multi-band joint detection and filter bank based detection, while in the sub-Nyquist wideband sensing, we find there will be multi-channel sub-Nyquist based sensing and compressive sensing. And for the type of the spectrum sensing that is used for coordination between the secondary users, we have the non-cooperative local sensing method and the cooperative sensing method. In the cooperative sensing method type, we find that there are centralized method, distributed method, and relay assisted method. While in the case of the number of radio frequency chains, we find that there is single node sensing and multi antenna sensing. So this is the complete picture of spectrum sensing that is used with radio location techniques. Now, in the case of non-blind spectrum sensing, the database supported sensing technique is very important and is used commonly with the wireless networks. Here there is a geolocation database. It gives a very complete picture of the spectrum that is used in a particular location. It gives the know-how regarding how the radio spectrum is being used. The database can be used to query various levels of details required by the cognitive radios. In this particular scheme, spectrum uses parameters of the primary systems such as place, time, frequency, and so on are stored in a centralized database. These can be used to develop profiles of the users, profiles specific to times, profiles specific to locations. Then there is one more technique, very significant, called the waveform or environmental parameter estimation, where we find that many levels of spectrum awareness is generated in a CR, which is required to have for controlling its power radiation, so that the co-channel crossovers or the nearby co-channel primary users' quality of signal can be protected. Further, environmental parameter estimation means that we are determining parameters that are related to the RF surrounding and not directly finding out the primary signal features. some of the parameters that can be calculated from the surrounding environment blindly using blind channel estimation are linked with the channel signal to noise ratio, direction of arrival, and the nature of sparsity. So then further we have a huge range of channel estimation techniques. One of them is pilot supported. Then next one is the blind techniques, and then the third one is the decision directed techniques. Then there is a mixture between the blind and the non-blind called the semi-blind techniques. While in the blind techniques, there are further subclasses called deterministic methods and the statistic methods, which are very relevant and bandwidth preserving, but their quality of service might be questionable when the fading is high. But with semi-blind techniques with some lower bandwidth capacity, we can have very high quality of service. And for the case of the DDCE techniques, we find that the hard iterative DDCE methods and the soft iterative DDCE methods, these are also used for decision directed cases through which we can find out the channel path gains. Now, if we are focusing continuously on the radio location, the signal to noise ratio is a very significant factor. Here also, there can be two broad categories of the signal to noise ratio related methods. Estimation method, one is the data aided, and the second one is non-data aided method. The first one has a higher spectrum preserving quality, while the second one has a lower spectrum conservation capacity. The data supported one gives greater reliability, while the second one has a lower reliability, but its bandwidth utilization is better and is more suitable for use with the beamforming based techniques. Sparsity order is a very significant parameter used in context of wideband cognitive radio and can be defined to be the ratio of the filled up carriers to the total number of carriers used all throughout the bandwidth. This parameter provides the details regarding the percentage of the licensed band that is free for the secondary user. So there are four different bandwidth estimation tools. These are called pre-hop capacity estimation tool. Then there is the end-to-end estimation capacity estimation tool. Then there is one more end-to-end available bandwidth estimation tool, then bulk transfer capacity estimation tool. Now let's find out the key spectrum awareness attributes. The first one is called the DSA, Dynamic Spectrum Assess, linked with the cognitive radio. So here there is an opportunistic spectrum control paradigm. Its behavior and performance depends on the primary spectrum activity. Then the second one is the knowledge regarding the spectrum activity statistics. So what are the spectrum decisions, predictions of the future spectrum occupancy parameters, selection of the channel band of operation, spectrum radio resource management decisions. Then the last one, these are quite relevant topics of research, how we have more details of the spectrum sensing methods, more and more new methods, spectrum activity statistics, modeling of the spectrum occupancy patterns. Now, how we collect the data? So since we need to have models created, so how we can create the database for creating mathematical or computational methods. This can be done from field measurements. So with the help of certain devices that are there with the wireless service providers, we can in the wireless profile or in the wireless spectrum determine the slots that are given to the license user or deallocated slots for the licensed user, newly reallocated slots to the licensed user. Sometimes due to the traffic congestion, some new slots are given to the licensed user through a boosting method. So all these profiles can be determined, or a database regarding the use profile of the spectrum can be created by a continuous monitoring of the spectrum and field measurements by the use of certain spectrum related devices. So here we can in the second phase generate a one-to-one mapping between the filled up and the pre-allocated or free subbands. Then through that we can further figure out the subbands that are boosted. So this will be location specific, or this will be time specific. So the time specific or location specific pre-allocation or free or filled up slots, boosted slots, uses by the primary user or the reallocation to the secondary user. These sort of details can be found out from on-field measurements. Now, what are the statistics that are necessary for creating a spectrum profile, which will be critical for determining how to use the spectrum better? These are characterized by the interference, path loss, faults in the wireless link, then delay, link layer delay, and the holding time, the time for which the spectrum was captured. Then then there is a critical factor called spectrum decision. Once all the related details regarding the spectrum bands are known and its characterization is complete, so the specific spectrum band that can be deallocated, reallocated, given to a primary user, secondary user, all these decisions can be taken, and then the quality of service requirements that should be maintained or that should be reached. These sort of decisions are taken based on the spectrum statistics. Then there is one more factor called the spectrum mobility. So it means that how one user, one subscriber can move from one particular location or one particular band to a different one. So in spectrum management and spectrum mobility functions, application, transport, routing, medium access, physical layer functionalities are carried out in a cooperative manner, considering the dynamic nature of the underlying spectrum. So as we see here, there will be a spectrum mobility function. There at the left side, there will be a spectrum management function. So between them, there will be the application layer, transport layer, network layer, link layer, and the physical layer. Sensing will be taking place at the physical layer level. So this will be passed on to the link layer that will deal with the link layer delay, which will be further dealing with scheduling and reconfiguration factors. Then there in the network layer, there will be the routing mechanism carried out and the reconfiguration required for the routing part. And in the transport layer, there will be the handoff delay or losses calculated and the reconfiguration required for that. Now all these characteristics, all these factors are critical for providing spectrum mobility to the subscriber. So spectrum mobility is a very significant factor. It depends on the network, how well we change the network protocols, how we change the channel condition, and how well we can manage the spectrum. So these are very cyclically linked. Then DSA, dynamic spectral allocation, is the most critical part in the cognitive radio based radio location technique. So its fundamental purpose is to manage the spectrum utilized by a converged radio system and share it between the participating radio networks all throughout space and time to increase the utilization of the spectrum. So it means that this DSA will try to find out the free slots, reconfigure the spectrum utilization, reconfigure the free spaces of the spectrum, and then tell the prospective customers the specific bands that can be used for the required task, for a required purpose. Now, how this is linked with spectrum sharing? Now, DSA is required for a smooth spectrum sharing because measurements suggest that many of the spectrum bands are unutilized for a considerable length of time. And with the growth of the wireless application, there is a significant requirement to find out the free spectrum and use them to fulfill the demands. Generally, spectrum sharing is a very closely coupled technique with DSA, dynamic spectrum assignment. In 2002, the US government created a spectrum policy task force which recommended the use of the spectrum sharing technologies for proper management of the wireless spectrum. And from that time, spectrum management and DSA has become a critical factor of all wireless management techniques. So how DSA works? So when a subscriber comes into a radio spectrum or starts to use a radio spectrum, it will be first regarded to be a secondary user. So it will be first given, or its rights or its or its users' rights will be considered to be lower than the license users. So therefore, the secondary users must do all the needful to minimize the interference for the primary subscribers. This means they must determine when primary users are not using a particular band, what frequency range is free, how to share the spectrum with the remaining secondary subscribers, when primary subscribers will begin to use the bands one more time. So transmission opportunities are referred to as spectrum holes, and these can vary in space, time, and frequency. So here is a depiction. So when a new subscriber comes in, it will be considered to be a secondary subscriber, and the DSA mechanism will try to find out the slots that are free, and once the slots are determined, these referred to as spectrum holes. The subscribers that are vying for use will be dynamically given the free slots for use. So this particular mechanism prevents the wastage of the bandwidth and maximizes the uses of the spectrum. So there are several methods of linked with the DSA. Some are called fixed methods, some are contiguous methods, and some are fragmented methods. Now, in the case of the fixed methods, which are very common in the regulatory framework, the slots are fixed. So there can be many radio access networks that will have free slots in the frequency spectrum. So here we see that in the time and region plane, we have the permission given to a particular range of frequency for radio access network 1 to use them. And in the second slot of frequency, we find for certain time and region, the second radio access network is free to use. But then in the case of the contiguous method, we find that the contiguous block of the spectrum with variable boundaries are pre-allocated dynamically to different radio access networks. So if at some point of time or in some region, radio access network requires a greater chunk of the frequency that can use it, then the guard band will be in a different point. While in some different time or region, we find that the radio access network 2 requires a bigger frequency. That way, that can also be given. So it revolves around the requirement. As per the requirement, the continuity is broken, or the fixed pattern is broken, and a contiguous pattern is developed for users by different radio access networks. And in the fragmented one, we find when there is a requirement by one particular radio access network at different space or time or region, that particular frequency slot can be given to that particular radio access network. That way, the network's capacity goes up, network's bandwidth utilization also goes up. It is a fragmented or dynamically created channel or spectrum segmentation technique. Then there are several newly developed methods. One is called the temporal and spatial DSA. DSA, when it is run at different slots of time, is called a temporal DSA. And when DSA is run at different locations of the network, we call it to be a spatial DSA. The UMTS, that is the backbone of the third generation mobile cellular system, which we still use very widely in our country, is based on both this temporal and spatial DSA. So we find that when DSA is linked critically with a time-based segmentation, its frequency fragmentation will be focusing purely on time. And when in specific region we need tessellization or fragmentation or fragmenting the geographical location or the cell sites into several slots that can be used by the radio access networks with different locations or different slots for the carrier, guard band, so on and so forth, then it dynamically provides better utilization of the spectrum to and helps the network planners and makes the traffic congestion less. Both this temporal and special DSA are cornerstone of the UMTS third generation mobile wireless networking. So if we see that the characteristics between the performance between the fixed and the dynamic methods of spectrum reallocation, we see that the dynamic technique is much more reliable, and its user satisfaction level is much greater, with a spectrum utilization gain of more than 14%. So DSA has certain requirements. It needs to focus on the network, especially on the physical layer. It needs flexible frequency carrier tuning, variable duplexer or variable duplex gaps, distances between the forward and reverse links for frequency division duplex-based systems. Though frequency division duplex was considered to be a method of the second generation or first generation techniques, but lately fourth generation wireless methods are using frequency division duplex-based systems in a big manner. Further, the DSA requires a flexible receiver signal filtering technique. The required flexibility of the DSA can be generated by the use of software-defined radio-based reconfigurable systems. This is one of the key points to note. Therefore, for radio location based on cognitive radio, we find that in the real world situation, the implementation device is based on software-defined radio. Then there is one more technique called drive, that is a very critical component of the DSA used for radio location, called the dynamic radio for IP services in vehicular environments. Its fundamental purpose is coordination between radio networks and form hybrid networks to guarantee better use of spectrum with primary focus on the mobile multimedia services. It further provides mechanism for spectrum sharing between systems by the use of DSA. So in vehicular networks, this method is quite commonly used and will be a very critical part of the current and the next generation wireless systems. It can very well be compatible with GSM-based UMTS networks, well below the 1 gigahertz network, and can fully support multimedia services. So it has two methods or two ways to raise the utilization of the spectrum. One is called the spectrum selection, by choosing the optimum transmission technology for a given load scenario, and then continuously use the DSA methods. Now let's come on to the spectrum awareness tools. One of them is the beacon signals. There is a control signal continuously flying between the base station and the subscriber. So it gives us the perfect picture, but it requires a coordination between the primary and the secondary user. It changes in legacy radio systems and might create economical cost or technical problems. Then one more method is called the database. It merely provides precise contents, but it relies on an external system. Technical, administrative, and legal problems might come up. It has the necessity for geolocation in DSA and cognitive radio terminals, so cost, location, precision factors come up, and database updating rate is a dynamically varying factor. Then spectrum sensing is used, so it does not rely on any external system. No changes required to the legacy primary system. It's quite simple and its cost is also low and suitable for dynamic spectrum bands. But sometimes it can provide faulty content too, so faulty details can also come. Then there are a wide range of spectrum sensing methods. There can be trade-offs with regard to detection performance, complexity, computational cost, and applicability. While applicability depends on detailed knowledge, which requires a range of precise match filters, certain features which will be based on feature detectors, mainly based on cyclostationarity and pilot carrier detection, correlated signals where sampling will be a factor, and multiple antenna structures, which can be done by the use of the covariance detector. And if we are facing a situation where there are no prior details, we can use the energy detector. And if we think about a very idealistic sensor, it must be simple, low complexity, low computational cost. General applicability means its capacity to detect signals of all formats and types, and high detection performance. So it must have high detection probability and low false detection probability. So if we see that if we use spectrum sensing by relying upon the energy detection method, we find that one such work reported way back in 2012 showed that combination of spectrum sensing based on energy detection is quite a reliable one. Activity statistics similarly help in proper spectrum sensing in support of radio location. So relevant spectrum and radio resource decision-making process is very critically dependent on the activity statistics. So spectrum activity can be found out from estimation and from the sensing observation. So sensing observations are linked with the inferred period duration, compute the activity statistics, minimum period duration, mean variance, the distribution. These are the key factors that can give a near perfect spectrum sensing capacity with high signal to noise ratio. But there are some practical limitations because spectrum sensing in all situations might not be perfect, and we might be facing lower spectrum to noise ratio situations. So what are the relevant factors? So the relevant factors are the activity statistics, which tells us the duration between the free and the filled up periods, and more sophisticated matrices like the channel load, duty cycles, and so on. Practical limitations are like the distortions in the sensing performance, finite sensing period, limited number of observations, and so on. And what are the different factors that needs to be analyzed are what are the activity statistics estimated by the DSA and the CR terminals in real conditions, the difference between the estimated and the real spectrum activity statistics, and what can be done to minimize the estimation distortion. Now there is one more factor called the spectrum occupancy modeling. So spectrum activity can be used to parameterize the spectrum occupancy model. So spectrum occupancy models are used for the analytical studies, simulation tools, design, dimensioning of the DSA and the CR networks, design of DSA and CSR techniques that are new, then spectrum measurements, models based on the real spectrum data, and there are challenges linked with the harmonization and synchronization of the methodology, field measurements, equipment, post data processing, and so on. And relevant parameters to be modeled are time dimension parameters, channel load, period durations, correlation properties, then frequency dimension parameters like statistical distribution of the duty cycle, clustering of the duty cycle, number of free channels at a point of time, and space dimension parameters like perceived spectrum occupancy level. Then we will go to the multiple. Then we go to multiple signals in space and channel awareness. In primarily in the multi-out system, we find that there are paths between multiple paths between the transmitter and the receiver, and each path becomes a channel. The receivers benefit from the knowledge of the channels. In the MIMO system, the channels know-how, when used in the network, raises the link reliability level. The topology of the network becomes dependent on this multipath and is used for the benefit of the network's capacity. MIMO with cognitive radio features have better channel gains and better throughput. So we therefore find that lately there is a tremendous rise of combining of techniques combining cognitive radio and antenna diversity, especially in the multi-out format. So here there is a guarantee of the services by the use of the MIMO. The link reliability goes up, and channel capacity also goes up, because there is a balancing between spectrally adaptive and spatially adaptive techniques. So we find here that frequency spectrum awareness plays a very significant role, and diversity selection of the antennas play a very significant role. So here is such sort of a diagram. This is called a adaptive generalized space shift keying, where the key part is played by a cognitive radio. It continuously uses the service of a machine learning based detector and a CSI channel state information estimation, gives a continuous feedback to the transmitter side, which continuously makes fresh copies of the pilot carrier, relays it, sends it to the receiver side, packing it together with the transmit block. It raises the quality of the service. So we find that that location awareness in the nature is quite relevant. Bats and the human beings use it quite frequently. We find location and the environment sensing to be done by the bats, especially to survive. So this part, how the bats work, they transmit radio signals. They will hit in specific targets, come back, and then tells the bat what the topography is like. So therefore, this sensing of the location is too also very much found in the wireless network. So location awareness is a method through which we can switch on the sensing capabilities. We can learn the surrounding, have a framework for decision making, and then use it for continuously updating the location details. This sensing of the location is used primarily for location-based services, and location-based services have become very much relevant with the wireless networks because people are very much conscious regarding the quality of service. So for better quality of service, location awareness has become a very relevant system in wireless networks. So a cognitive radio system with sensing elements can give us location details. So there can be in the system there can be a sensing block. The sensing block will have a sensor and the ADC. The sense content will be converted to a digital form, sent to a processing block, which will be processed on by a processor and held in memory. Then there will be a transceiver block based on cognitive radio principles, but formulated by the use of a software-defined radio with a front end of the RF type, which will be connected with the antenna sections. So here is a mechanism through which we can see how location awareness can be provided in with a cognitive radio system. Now, if we have a wireless environment, it first sends the data to a sensing layer. This particular sensing layer generates a waveform. It goes through a adaptive waveform processor. It generates location awareness, spectrum awareness, and the environmental awareness goes into a cognitive device, and all the details generated from this part, from the cognitive system, goes to a waveform generator, which is an intelligent one. It will be further generating a very relevant waveform and will be sent for wireless transmission. So what are the sensing interfaces required? These are done in three main categories. One is done through the radio sensing, one is done through the radio vision, and the third one is done through radio hearing. Now, sensing method, radio sensing is a technique that will use the electromagnetic sensors and related post-processing schemes. Similarly, radio vision is a sensing method that will use the image sensors and corresponding post-processing techniques. And finally, radio hearing is a sensing method that will use the acoustic sensors and related post-processing schemes for determining or for providing a set of sensing methods used for location services. So radio sensing use mostly, the most widely used radio sensing sensor in the wireless system is the antenna, that is a transducer that converts an electromagnetic signal into an electrical signal and vice versa. So in a antenna-based wireless positioning system, location details are calculated from the time of arrival, signal, receive signal strength, and the AOA, angle of arrival. So here is a such sort of a sensing mechanism. So first we have a sensing antenna capturing the details of the wireless sensor. Then a spectrum sensing module will be there that will be figuring out the data. Then there will be a spectrum decision block that will find out the spectrum holes, and finally there will be a switch controller, which will be a switch activation circuit required for the use of a reconfigurable antenna system. Then we come to the radio sensing methods. These are range-based schemes, range-free schemes, and pattern matching-based schemes. Cognitive positioning systems that are designed by the use of smart or reconfigurable antennas are used to design these three schemes. Then let's come to the radio vision sensors. First, it will be capturing certain scene, capture the optic signal from the and then convert it to an electrical signal for forward transmission. Variable computing devices such as video camera signal from the scene are required and sent to the cognitive radio. The captured content can be processed by the use of digital processing techniques like pattern matching and machine intelligence techniques. So here is a vision-based sensor system. So very much relevant for a robotic process control system in a factory. So here there will be a vision system where there shall be a control, there shall be a microcontroller, there will be a RF transmitter, a camera, that will have a bidirectional link to a robotic system where there will be RF transmitter, a motor shield, and a microcontroller. This can be used very effectively in a factory, in a process control setup. Then radio hearing sensors. Radio hearing sensor is an acoustic sensor that is a transducer that converts the acoustic signal into electrical signal and vice versa. The main concept behind the acoustic technique is the use of the sound propagation to navigate, detect, and communicate. So wireless systems use the acoustic signals for cognitive location and the design of environment sensing systems. Radio hearing, cognitive radio can acquire sound signal and use it to be a pattern. Further, it can look towards the spectrum of the captured sound pattern and compare it with the spectrum pattern stored in the database to take some decision regarding a location. So here is a mechanism which tells us how location sensing can be done. So for location sensing, there can be a location sensor. It captures the location details and passes it through a location sensing code. It has location sensing applications. It has statistical learning and tracking, mobility management, then seamless positioning and interoperability, and further it has security and privacy concern. Further, all these details come to a cognitive radio system that gives the decision regarding location sensing and decision derived from location sensing processes. So what are the key factors linked here? Seamless positioning and interoperability, security and privacy, statistical learning and tracking, mobility management, and location aware applications. Next, we come to the environmental sensing. These are linked to the topographical content, propagation characteristics, and meteorological profiling. So here, similarly, there shall be a sensing mechanism on the top. It gives the details to a sensing core, which will be doing the processing, deriving decision rules, and stored in a system for making the decision. This can be linked with the topography, meteorology, recognition and tracking, propagation channel characteristics, and so on, through which the decision regarding the wireless surroundings can be generated. Then how we can find out locations, specific one, positioning. It can be physical or virtual. Physical one is represented through coordinates of a single point in space. Virtual location is determined through IP addresses, that is, which is relative to some known entity whose physical location may or may not be known previously. This type of location content is commonly faced in wired networks such as World Wide Web, mostly in the wireless format. So mostly in the wireless World Wide Web format, this part is quite critical. Positioning is quite critical. So how that is done? So location details are picked up. That is first verified. in the physical format. So if it is to be found out to be absolute or relative, so it can be dealt with numerous reference coordinates like the NAD, the ED50, the Tokyo datum, and the ECF, and the World Geodetic System, Geodetic System, so on and so forth. So that way the location content is dealt with. So there are three classes of relative location determination. One is 1D, location of a cognitive radio in a single axis, X, Y, or Z. So distance between a transmitter and the receiver. Second one is a two-dimensional reference of a cognitive radio in a plane. So both the two axes shall be there. Type of location content, such type of location videos can be found from current wireless system. And third one, the second one can have the length and breadth part, and the third one can have the time factor too. That can make it to be a 3D cognitive radio where the relative location details are known with respect to length, breadth, and time part. So how is statistical learning and tracking relevant for location sensing? So the mobile cognitive radio users, they have the location details generated. So the dynamic radio parameters are fed to a statistical learning and tracking system that learns continuously, creates its own decisions, has its own rule base and decision set generated. That way, where and when required, the decisions can be provided. So here is one such method through which statistical learning and tracking takes place. So from the RF surrounding, sensors will pick up the contents. The sensors will feed the data to the sensing mechanism that will feed it to the learning platform. Learning platform will do the statistical learning and create certain decision, which where and when are required will be converted to specific process control mechanism. So before I conclude, I would like to request spectators to raise one or two quick questions. I shall be pleased to reply to the queries. I hope that the talk was beneficial to you all.
I request if anyone is having any queries, they can ask.
Anybody having any doubt, any question on this? All the participants present, if you have any query, you can ask to our Professor Kumar Sarma sir. Okay, if there is anybody having any query, okay, any question, any doubt?
Yes, sir, myself, Dr. Charmani Sagatika, I'm having a single doubt.
Yes,
Not doubt actually. Sir, you talked about many tools of spectrum awareness tools, beacon signals, databases, spectrum sensing. Out of all the tools, which one is the working the better one?
Yes. Beacon is the most common one. Beacon is there in all types of BPSs, base stations. With the help of the beacons, the base stations will be maintaining a link with the team, that is the subscriber, and the beacon will be further used. That the beacon channel will be used further to collect the content from the subscribers end, and the wireless profile so that the know-how regarding the wireless scenario can be continuously monitored and stored, and the pilot carriers that way varied so as to make the link reliability better. So the beacon is the most commonly used method for doing the spectrum sensing, primarily at the base station level. While in our user side, our handheld devices, wireless devices, they have their own capacity, own system, similar to a beacon, through which they can make a distinction between varying signal strengths. So if there is a net connection, your SIM has a net connection, net track. But if there is a nearby Wi-Fi router that has a better signal strength, you might be seeing, I'm sorry, that the handheld device shall be shifting stronger signal. So your handheld device, it also has a beacon. Similarly, there is a beacon at the base station also. The technology of the beacon is continuously changing, becoming better, and that way wireless sensing capacity both at the base station level and at the user level is becoming better, and therefore the beacon continues to be a very reliable sensing mechanism.
Thank you, sir. Thank you. The talk of radio location and cognitive techniques is really nice. I'm very glad you explained it so nicely. Thank you.
Thank you, Professor Kandarpa Sarma sir, for your excellent presentation on radio location and cognitive techniques. If I summarize your talk, basically it is about radio location is an important method for wireless communication. These are important for localization services. Due to variation in wireless propagation channel and uncertainty associated with location services, conjugating methods are found to be important elements of link reliability and quality of service. Sir, you have discussed some of the issues linked with radio localization and application of conjugative principles.
Yes.
Thank you, sir. Thank you for giving your valuable time.
Yes, nice talking to you all. And I too also have been quite blessed for giving me this session where I could share my know-how and learn from you as well. Thank you.
Thank you all. Okay, thank you, sir. Thank you all. Today, this is the end of this session. And for today, our conference, this is the end of the session. Again, we'll meet tomorrow at 10 a.m. Tomorrow, the speaker is Professor Durga Prasad Mahapatra. Till now, this is the end. Thank you all. Now you can leave the meeting.
So as the meeting terminates, I'm closing of the meeting on behalf of METASOFT 2022. Thank you. Thank you all.
Thank you all.